So now another method which is more accurate is the trapezoidal method. So the trapezoidal method consists of approximating the integral as sum of area of trapezoids constructed upon the points xi and xi plus 1. So as you can see here, you can approximate the area under this function in red as a sum of trapezoid, and you can see that it's already visually more accurate than the result obtained with the rectangles. Now, so the integral, the approximation for the integral can be written as the sum of II, where II is the area of a trapezoid constructed upon the points xi and xi plus 1. So what is the area of a trapezoid, okay, constructed upon the points xi and xi plus 1? So for a given trapezoid, okay, the area of the trapezoid is half of the product of the two bases, so f of xi plus f of xi plus 1 over 2 multiplied by the height of the trapezoid, which is h, or the spacing between the points. So it's h over 2 multiplied by f of xi plus f of xi plus 1. So the integral is h over 2, the sum for I equals 1 till n, f of xi plus f of xi plus 1. Now, by making a change of variables, you can substitute this sum, you can recast this expression into this one. So you get h over 2, f of the first point, plus f of the last point, plus h, the sum from I equals 2 to n of f of xn. So basically you get the same expression as the rectangle, but the only difference is for the rectangle, for the left corner approximation, we had this sum plus f of x1. For the right corner approximation, we had this sum plus f of xn plus 1. Right? Here, you take the mean value of f of x1 and f of x1 plus 1. So half of f of x1 plus f of x1 xn plus 1. Okay? So this is how you can relate the rectangle to the trapezoid. Even if visually it looks different, it's almost the same thing. It only differs by this value here, where it's the mean value of f of x1 plus f of x1 plus 1, f of xn plus 1. And now I will show you how to obtain this last expression. So, like we said, the integration with the trapezoidal method, the expression is this h over 2, the sum of f of xi plus f of xi plus 1 for I equals 1 till n. So now what I will do is that, okay, here for this f of xi, I will put the first term out of the sum. So this is f of x1 plus the sum of I equals 2 till n f of xi. And now in this second sum, the sum of xi plus 1 here, okay, for I equals 1 till n, I will put the last term, okay, out of the sum. But before putting the last term out of the sum, I will just like make a change of variable. So if I call I prime is equal I plus 1, okay, so here this sum goes plus sum I equals 2 to n f of xi. So now the sum will go from I prime is equal 1 till n plus 1 f of xi prime. Now instead of I prime, I will use here, okay, I, same thing. So f of x1 plus the sum of I equals 2 till n f of xi plus the sum of I equals 1 till n plus 1 f of xi. I equals 2 here, I prime equals 2, okay, till n plus 1 f of xi. Alright, so now I will put the last term out of the sum here. So I will get h over 2 f of x1 plus sum I equals 2 till n f of xi plus here, okay, f of xn plus 1, I put it out of the sum here, the last term, plus the sum I equals 2 till n f of xi. So I get 2 times here the f of xi, so I can express h over 2 f of x1 plus f of xn plus 1 plus, because I have 2 times the same sum here, it becomes h multiplied by the sum of f of xi. I equals 2 till n. Okay, so this is the expression for the trapezoid. So it's h over 2 f of x1 plus f of xn plus 1 plus h I equals 2 till n f of xi. And now if you want to develop a similar approach that we did for the rectangle approximation, so if you want to increase the number of subinterval until we get the integral up to a given precision. So first we will construct the trapezoidal with just the 2 points A and B. So h is equal to b minus a, and I1 is h over 2 f of a plus f of b. For the second step, then we have here the point C equals a plus b over 2, and we have these two trapezoids. So the area of the total integration is equal to h over 2, the first point plus the last point, plus h f of the middle point, f of a plus b over 2. So this is equal to I1 over 2 is h over 2 f of a plus f of b over 2 plus h f of a plus f of h f of a plus h. Now for the third step, so we have, I didn't draw it here, so we have 4, okay, trapezoid. And so we have h over 2 f of a plus f of b over 2, h being the previous h over 2, plus h f of a plus h plus f of a plus 2h plus f of a plus 3h. So this h over 2 plus f of a plus f of b plus f of a plus b over 2. Here this is the previous integral over 2. Okay, because h is equal here h over 2. Okay, the previous h over 2. So this is I2 over 2 plus the sum from k equals 1 to 2 h of f of a plus 2k minus 1h. Now for the general iteration at any step n, we find exactly the same expression that we found for the rectangle approximation. So we divide the spacing by 2, and this is exactly the same expression. So it's the previous integral divided by 2 plus the sum of the odd term from k equals 1 till n over 2, k f of a plus 2k minus 1 hn. It's exactly the same expression. So what does change in this iterative approach? The only change, okay, is here. This is the only change between, the only difference between the rectangle, okay, iterative approach, the left corner, and the trapezoid. So here we had I1 equal h over 2 plus f of a. We had h f of a for the rectangle, and here we have I1 is equal h over 2 f of a plus f of b. So this is the only difference resides in the first step. So the programs for this iterative approach is exactly the same. Okay, this is the same, exactly same algorithm, the same program. The only difference is in this line. Instead of hf of a, we have h over 2 f of a plus f of b. Okay, so now if we take the same program that we did for the rectangle, okay, I'll run it again, show you here. This is the same one. We had 21 iteration for a precision of 10 minus 6. Okay, and now if I only change, I will comment this line, and I change the value for the first step, h over 2 multiply by f of a plus f of b. And I'll run it here, and the number iteration is reduced to 11. So it's 2 times faster with the same result than the rectangles. And of course, for a given number of points, okay, for a fixed number of points, we get a better result with the trapezoid. So this is the only difference. It resides in this line here. Instead of I is equal hf of a, we have I is equal h over 2 f of a plus f of b.